Hello, everyone. It's my pleasure to introduce myself, Leanne Gilbertson. I'm an assistant professor in environmental engineering. My primary appointment's in the Department of Civil Environmental Engineering, and I have a secondary appointment in the Department of Chemical and Petroleum Engineering. This is my 6th year here at the University of Pittsburgh, and I'm excited to be a part of your recruitment event. I've included here my contact information, so my email address, my Twitter handle if you'd like to learn more about our group's accomplishments and things that we follow, and then also my personal research website if you'd like to learn more about our research and additional information on the things that I'm going to just provide a brief overview of in this video. My background is in chemistry and chemical environmental engineering. I received my chemistry degree from Hamilton College, and then my master's, PhD, and postdoc actually continuing at Yale University. So I have a great pleasure, and I've been very fortunate to mentor a wonderful group of graduate students, undergrads, postdocs, and MS students throughout my time here. Um, Overall, I would say that our group is very open and welcoming. We come from diverse backgrounds, we have diverse interests, and also diverse goals for what we're here for in terms of getting a PhD or pursuing a postdoc or master's degree. Um, we're very collaborative. All of my students are, fortunately, very intrinsically motivated and hardworking. And I also encourage to maintain a healthy work-life balance throughout their time here and with me and my group. And these are a variety of photos from, I don't know, the past several years. We've had a couple different weddings of group members. We have had some social events, and then some more formal photo events that turned into fun events at the end, up there in the upper right hand corner. So again, I've been very fortunate. It's a wonderful group of students. Um, you would be very welcomed into the group, and I think you would find it to be a very supportive environment. If you would like to reach out to any of these students, please feel free to let me know, or you can find them on my website, and then they would be more than happy to share their experiences working with me as their advisor. As I mentioned, I've had members at all levels of education, and this is very important to me to keep a diverse group of degree holders, I guess. Uh, Throughout my time here so far, I've mentored 3 postdocs, 6 PhD students, 6 master's students, 14 undergraduates, and we've had two high schoolers in the group as well. The postdocs and my 1 PhD student that I've graduated so far have gone on to successful careers. I have one postdoc has gone on to be a faculty of chemistry at St. Francis University here in Pennsylvania. Um, Another that's gone on to be a sustainability specialist at Owens Corning. And then my first PhD student that I graduated is currently a postdoc at Lawrence Berkeley National Lab. In general, or sort of the overview of our group's research is the design of new materials that are highly functional, so they maintain their performance, but what we're doing is we're manipulating them to make sure that they are inherently safe. And the reason we do this is to avoid future unintended consequences that have impacts on the environment and public health. We also evaluate the sustainability of the technologies that these new materials enable. To do this, we use systems level tools to evaluate impact and benefit trade-offs, to ideally do this early in the technology design phase so that we can inform redesign to make the technology safer, more sustainable, and again, avoid these unintended consequences through their use by thinking very critically about how we design them up front. To this end, we work at the molecular and the systems level, And my research group is a slightly more modeling than usual right now, just given I transitioned a couple projects to modeling when the lab shut down a year ago. But I tend to be majority research or empirical experimental work, and about 20% modeling work. Um, I'm highlighting on this slide sort of four main areas of research in my group. I'm going to start up at the top left with the mechanisms of interaction between materials at biointerfaces. This here is a representative image of some of the chemistries that we most recently looked at on graphene, specifically on nitrogen doping and the different nitrogen groups that we introduced into the carbon backbone and how these influence a particular electrochemical reaction. It's called the oxygen reduction reaction. And what we have found through this work and other dopants and functional groups that we add to the surfaces of carbon nanomaterials is that it tends to be these electrochemical properties, the ability of these active sites to donate or accept electrons, that drives both these electrochemical properties, but also the biological activity of these materials. And so this is a very, I would say, fundamental materials chemistry combined with sort of rational design, green design of emerging materials project. And this is really the bread and butter of my past research and the foundation of my group here at the University of Pittsburgh. And a couple areas that we have built off of this foundation, particularly looking at applications of this work. If we move down now to the bottom left, is looking at a metal nanoparticle, so specifically silver, and trying to understand mechanisms of resistance to silver nanoparticles and what specifically emerges from the particle itself and what emerges from ions that are released from the particle. And the idea here is to be able to, through understanding these mechanisms, be able to design these particles to be effective as antimicrobials without introducing resistance into the organisms that they're targeting. And then over here on the bottom right, what we've been doing is developing chemistries of a photocatalyst called carbon nitride, which it's a visible light photocatalyst. It means it can harness the visible light region, so lower energy light, compared to other photocatalysts like nanotitanium dioxide is the comparative nanomaterial that we currently compare our performance to. And what this material is being claimed as a sustainable material because of its precursors, because of its ability to be made from renewable organic materials, and also because it's able to harvest lower energy light to be activated. Both in our group and other researchers have demonstrated its efficacy against bacteria and a couple of different model viruses. And the graphic that I'm showing here is from a paper where we looked at a couple different bacterial model organisms and environmental strains, specifically thinking about the context of water disinfection. And this is a project that I'm currently looking for a student to take over. And so I look forward to the opportunity to talk to you more if this sounds like a project that's of interest to you. It's very much kind of in the vein of this material synthesis and kind of understanding the fundamental nature of the material as we change the chemistry of it. But then it's also going to expand in using the material in sort of model disinfection systems. So very much also a real application of the material, specifically for targeting opportunistic pathogens that we have on our drinking water train. And then up in the upper right is an area that I moved into when I started here at the University of Pittsburgh, and that's in evaluating trade-offs of emerging technologies in agriculture, specifically with the goal of advancing agriculture sustainably. So there's a major need for changing the way that we produce crops to feed our growing population, and then of course also the animals that provide food sources for us as well. And this is taken from a paper that's specifically proposing different nanomaterials that are used for a variety or being proposed for a variety of different applications in agriculture. And what this project really does is bring together my research at the molecular and systems level. And so I would say generally all of our projects, even though they are quite diverse in nature, fall under this umbrella of tackling grand challenges of engineering through sustainable design, integrating the molecular and systems level. We are highly collaborative in our lab. We enjoy working with other people. We enjoy the perspectives that they bring. And so a successful person in my lab will be able to work well with other people and also across disciplines. So we work with researchers in chemistry, within chemical engineering, within environmental engineering, geology and environmental sciences, and then also within and outside of the University of Pittsburgh. So there's opportunities to develop a network of researchers throughout your time in conducting research in my lab. And then we conduct our research in the Environmental Engineering Laboratory. This is a large shared lab in Benham Hall. We also utilize the instrumentation in the Peterson Institute for Nanoscience and Engineering. It's PINSE. It's in the basement and sub-basement of Benham Hall. Has really amazing and state-of-the-art equipment for characterizing and fabricating nanotechnologies and nanomaterials. And then the materials characterization lab over in chemistry has some instrumentation that we utilize. Most that we use is the X-ray photoelectron spectroscopy, or XPS, for surface characterization. And then finally, I want to end with, we're in this together. When you start a PhD, you are starting a new chapter of your life. It's a big chapter. It takes a lot of commitment. It takes a lot of grit. And, I'm here to help you, and really excited and gain a lot through the mentorship and the relationships that I develop with each one of my students. And so it's something that is a mutual venture, and is one of the reasons that I have pursued this as a career, is to be a part of your lives and be a part of your growth. To that end, it's really important that you develop your skills within research, but the specific skills that you're going to acquire are highly dependent on the project. But in my group, they mainly revolve around material synthesis, materials characterization, some microbiology, environmental chemistry, and life cycle assessment. And then I work one-on-one with my students to develop an individual development plan, and this kind of sets the stage for being able to have conversations and set goals that we visit biannually to in terms of the professional goals, and ensuring that we meet markers and have some developmental milestones that we meet along the way. And then collectively as a group, we help each other build effective oral communication skills, effective written communication skills in both of these cases, specifically in group meetings, helping each other, providing critical and constructive feedback in both of these domains, which students I think have found really helpful. And then also sound research methods and approaches, and of course, building a healthy community. And so with that, I will end and welcome you to reach out to me. I'll go back to my very first slide for contact information. Reach out to me if you have any questions. I'm happy to connect you to any of my students if you're interested in hearing from them about how I am as an advisor. They're the best to be able to tell you. Yeah, I hope that you all come to Pitt.